Hello everyone and welcome to another video. So today's video is going to be the start of a new series, one where I attempt to take this material, iron ore, and turn it into a usable final product, ideally steel. Now, this process isn't very simple. It's a lot easier said than done to turn iron into steel, a lot more difficult than other materials. Which is why I'm only saying I want to get steel, but I might actually not create it. I won't get too much into the process today, but it's quite difficult. It's not as simple as, say, refining copper, casting that. This is a very difficult process, and chances are there might be a lot of difficulty. I'll probably create some cast iron and utterly fail to really achieve enough heat before I'm actually able to finally make steel. You can expect a lot of failed trials in the early episodes of the series. But that's not what this video is about. I figured that it would be best to first talk about the ores that we'll be dealing with. And, you can't create a final product if you don't have the natural material to work with. So these are some various grades and types of ferrous ores. There are actually two of these I'll get to later that aren't on the table, but more of that later. These four, up to here, are primarily iron ores. These I'll get to later. I'm pretty sure they're not just iron. So on the left, we'll have this high-grade magnetite ore. Now, this is probably actually too good for the purpose that I'll be using it for. This is direct shipping ore. It can be thrown directly into a blast furnace, a modern blast furnace. I don't have a blast furnace. Blast furnaces are huge, bulky machines that make a large amount of steel, and they don't exactly sell them at the hardware store, if you know what I mean. So, that's not the route I'll be going. So this ore is not all that useful to me because it is actually too dense of an iron-bearing material to use in the way I need to refine it. You actually do need stuff like silica and other materials that aren't iron ore in order to actually properly refine it. Think of it as you have to dilute like soy sauce to make it taste good. It's sort of like that. In order for the refining to actually produce good steel, I need to dilute the ore, the magnetite, iron-bearing part of the ore, with other materials. Not to mention, it's a bit of a walk and effort to get this material, so this will probably just stay as sort of a museum piece, I guess. And as you can see, a little closer, and the magnet sticks extremely strongly to the surface. What I will be using for my high concentration ore is stuff like this. It is also quite a bit of iron. You can see magnet sticks quite strongly. You'll notice that this ore is slightly different as it contains silica instead of the limestone that this ore is associated with. And silica is important because it forms slag, which is removed during the refining process. If you can't form slag, which is essentially glass, the finished product doesn't come out well. At least that's what I can discern from what I've researched. But in all honesty, these ores are not going to make up the majority of what I smelt. I'm going to be doing blends, and these will be a small minority, simply because they're not as available. At least that's the original thought. What is available are huge rocks like these, which are only slightly magnetic. They have little black flecks of magnetite in them. But what really sets it off that they are iron containing is this blue hue coloration, as well as these reds and oranges. This is created by bacteria leaching the iron out of the rock. Now, depending on which rock I get this from, the iron concentration will vary. And I'm going to have to blend mixes of these pieces, in order to get the desired concentration I'm after. In addition, these types of ores will introduce trace minerals and elements that can either help or hurt the final product. Now, as you can see, if I put the magnet next to it, it is sort of attracted. You can see it move strangely. I think if I hold it close, yeah, it'll hold for a bit, but it's not all that magnetic. It's very easy to fall off if you place it in the wrong spot. But actually, this is a pretty good iron-bearing ore, which is why the blue hue is so pronounced. And then we have stuff like this, where the blue hue is barely present. There's barely any iron in this. It'll sort of hold the magnet a little bit, but not that much. Yeah, it really depends on where you place the magnet, because the iron is in the form of little magnetite grains in the rock. So in some places there's not going to be any, in other places it'll have a strong connection. In addition, rocks erode and contribute to the soil, and since these rocks are native to this region, there is quite a bit of iron in the soil, in the form of smaller pieces that are going to be like this, down to sort of iron filing size, very, very small, and a couple that are more like this. Put it this way, if it is picked up by a magnet, it contains iron, and it's probably going into this process at a certain point. Unfortunately, I actually don't have any footage to show you of that material. You'll just have to imagine it. Why don't I have any footage? Well, all of my loose ores are outside at the moment in buckets and bins. Buckets and bins collect water, and it's winter out right now, so currently all of my loose ores are encased in blocks of ice. Oh well. And anyway, the loose ores actually have to be processed further. When they're big like this is actually probably perfect size to go into the refining process. Maybe a little bit too big, but you get the idea. They have to be reasonably small, maybe like that size, in order to go into the process of refinement. If they're too small, they'll pick up too much carbon, they'll turn into cast iron. So loose ores that are even smaller than this, smaller than the desired size, will actually have to be bound together with limestone and clay. In fact, that's usually how they do it in industry nowadays. And then lastly, the lowest grade of ore is this orange muck brought about by iron bacteria, chemosynthetic bacteria. And this contains a lot of trace elements, but it also needs to be put into pellets with other materials in order to process it. And finally, we have the Wildcard. Remember how I talked about trace elements and additives? Well, you'll notice that these rocks are, well, that looks like one of those. It looks like it would be pretty strongly magnetic. It's magnetic, all right, but not strongly at all. Doesn't click the same way that the other magnetite does. And that's because this is some sort of other ferrous material. I'm not sure what it is. It could be chromite, it could be franklinite, although I don't think it is. But it could be a whole number of things. I really can't tell. The reason I bring this up is because it might come up in a later video. I don't plan on melting this one down, maybe this one or something like that. The reason is because you really don't want to add too much trace minerals and elements to steel, otherwise then it starts causing problems. For instance, if this is chromite, if I add too much of it, the steel will become way too brittle. Well, at any rate, hope you all enjoyed. I hope you guys stay tuned for more. See ya.